Hey everybody, and welcome back. Okay, so you've done your literature survey, you've maybe found something that was relevant to your hypothesis, or maybe you even found that somebody else has investigated this before. Now we're going to get to the really exciting part. You're going to design an experiment to actually test your hypothesis. Because remember, a hypothesis is something that you can check, and where in a hopefully relatively simple manner, especially as it involves computers, so you just run something on the computer ideally, you can find out whether your hypothesis is true or whether it is false, and then based on the result of your experiment, you can adapt your hypothesis, you can develop additional hypotheses, and so on and so forth. Okay, that's what we're going to do now. Really, the focus of this is on the design of the experiment to test your hypothesis. Doesn't necessarily mean that you need to run this because you might not have the resources, or it might be very difficult or very time consuming or resource consuming in some other way to run this experiment. But the main purpose of this exercise is really to get you to think about the different things that you need to take into account when you design an experiment to test a hypothesis. And it turns out that in practice, this is actually really, really difficult. If you have a background in science, you might be aware of this already because running an experiment in science means that you have to take into account all kinds of different conditions, right? So it's not just about the experiment itself, it's also about the environment. What's the temperature? What's the humidity? What is the pressure? Is it raining? Is the sun shining? Is something else going on? Is there a truck driving outside? All of these things can affect the outcome of your experiment, so you have to be very careful when you design your experimental conditions so that you don't end up with something that looks like it might prove your hypothesis, but it's really only because you have not taken something into account that affected the outcome, and in practice you haven't really proven your hypothesis at all, but maybe you've even refuted it without realizing that. Now, fortunately, in the context of computer science specifically, that is a little bit easier than in other fields of science because we're running everything on a computer here, right? And that means that you have very nice and good control over what happens. If you run an experiment in a lab and that is not climate controlled, you have very little control over the temperature, unfortunately, and that might affect your experimental results. In computer science, in many cases, that's not really the case. You can control the environment very neatly, and that allows you, hopefully, to come to better conclusions with respect to the hypothesis that you're investigating. Okay, the other thing I want you to consider when you're designing your experiment is what happens if your hypothesis is not true. Is your experiment simply going to tell that, or is it maybe also going to give you an idea of what might be true? And that's very important in practice. You run some experiment, and that might be a computational experiment, but even that might take a very long time. For example, because you need to run it on 1,000 computers, and your computations will run for hours and hours or days and days. So ideally, the result of an experiment doesn't only tell you something with respect to the hypothesis that you're investigating, but also maybe a hint to what might be wrong with it if it turns out to be false, or if it turns out to be true, maybe some additional information that you can then use to come up with new hypotheses or develop a new model, develop a new theory, whatever the research endeavor that you're pursuing might be. So think about this. Of course, if you have come up with a hypothesis where you can yourselves test whether it's true or false through an experiment, feel free to do that in a very empirical fashion. Run an experiment and then come back to it and see, oh, okay, hang on, could I have designed this experiment in a better way? Maybe if I measured something in addition, or if I set it up in a slightly different way, I would be able to get more information. I might be able to get something with respect to another hypothesis. 2 in 1, great thing, right? Run one experiment, learn something about two hypotheses, great. That's the kinds of things that I want you to think about. And if you have come up with a hypothesis that is very difficult or very time-consuming to test, then this will be a more abstract exercise for you. But I still want you to consider and think about all the different things that could affect the outcome of your experiment and what they might tell you about your hypothesis. All right, have a go at that.